Welcome to this SAP Tech Bytes series on SQLScript in SAP HANA Cloud. So in this series, we will explore the SQLScript language and how to create stored procedures, user-defined functions, and user-defined libraries in SAP HANA Cloud. We will follow the SQLScript in HANA Cloud tutorial group, which is available on developers.sap.com, and we will use the SAP HANA Cloud trial on our SAP BTP trial account to complete these tutorials. So in this first video, we'll go through the first 3 tutorials of the group, covering how to create stored procedures, using parameters, and leveraging parallel processing, and then finally, how do we use intermediate table variables. So let's get started. So like I mentioned, we're going to be using the leveraging SQLScript in SAP HANA Cloud tutorial group on developers.sap.com. And for this first video, we're going to go through the first 3 tutorials of the group. So creating stored procedures, parallel processing and parameters, and then intermediate table variables. And then the next videos will cover user-defined functions in the next video, and the video after that we'll concentrate on user-defined libraries. And then maybe we'll wrap it up with some of the aspects around the tooling, using anonymous blocks in the SQL console and debugging stored procedures, and then finally using some techniques working with table variables, index-based cell access, and table variable operators. So let's go ahead and get started with the first tutorial, creating stored procedures. And I'll just move this one to the side for now. But before we do that, just know that it expects that you have done some things prior to starting this this particular tutorial. We assume that you have already created your BTP trial and your SAP Cloud HANA Cloud instance trial. If not, just follow the links that are here that show you how to do that. It also assumes that you've configured your Business Application Studio. If you haven't, go ahead and follow that tutorial as well. The first step that we want to do is to create our project in the Business Application Studio. And because we want to get into the meat of SQLScript and store procedures and all that fun stuff, we don't want to waste too much time with setting up tables and putting data in tables and things like that for our sample data. So we'll have you import that. And that stuff gets created for you automatically. So let's go ahead and do that. I'll move this to the side here. So the first thing we have to do, again, is create a project. So I'm in the SAP Business Application Studio here, and I can go ahead and click on the Start from Template. Then I can choose SAP HANA Database Project and click Start. I can give it a name. In this case, I'll just call it DM. Click Next. And then I'm going to keep DB as the name of my module. So here, no namespace, no schema name. It's the HANA Cloud database version, and bind the database module to Cloud Foundry Service Instance, yes, and click Next. Okay, I'll go ahead and put in my email address and password. And click Login. And I'm able to choose my org and my space. And I'll click Yes for new HDI service instance. This is good. Use the default database instance. Yes. And click Finish. And now it's generating. Just take a couple seconds. Okay, and it looks like we've created our project successfully. So now we can come to our source menu, folder here. And here's where we're going to import the data.zip file that we've downloaded in step 2 of the tutorial here. So we'll go ahead and right click on source and say import project and choose data.zip. It's brought in this folder called data, and then with all of these artifact files here, these HDB tables, and this is all of the tables that we'll be using, like MD addresses or business partners, employees, products, purchase orders. So these are the tables that we'll use during the tutorials. So at this point, we can go ahead and do a deploy. So if we come down here into SAP HANA projects, we can select our module and click the deploy button here. And that came back successfully. That looks good. So now we can actually go to the container in the HANA Database Explorer. So we can go ahead, click the Open HDI container, and that takes us to the SAP HANA Database Explorer, where we can go ahead and look at our tables. So for example, let's go ahead and do an open data preview on the employees table. And we have all of our data in our table here. Okay. So now that we have our tables and we have our data, we can get going on learning about stored procedures in SQLScript. So the next section, step 2, in this tutorial, we want to create a new folder. So let's go ahead and create a new folder under source. Say new folder, let's call it procedures. Okay. And then from here, we want to click view and find command, type HANA here. And we want to choose the wizard for create SAP HANA database artifact. Okay. And looks like the correct folder has already been selected. If it didn't show procedures as the folder here, you can click this button and browse to it. Sometimes in my experience, it's not always pointed to the right folder there. We'll keep it as HANA Cloud as the version, and we want to change the artifact type to HDB procedure. If I can find it in the list here. Oh, there it is. And let's give it a name. Let's call it get PO header data. Okay. And we'll click create. See a message down here that the snippet has been created, which means that it's created the file for us. It hasn't opened in the editor, so we have to come over here to the actual file and click on the file to open it in the editor. Okay. Next step, we want to add a little bit of code. So I'm going to copy and paste this code from the tutorial. I'm going to put it right between the begin and end. And in this case, let's just take a little bit of a detour here and explain what we're looking at. So this is the basic shell of a procedure. Okay. So we have the procedure statement with the name of the procedure, and then parentheses after that. And within those parentheses is where we would put our procedure signature. So our input or output parameters would go there, which we'll see in the next tutorial. The next section here is what I refer to as the metadata section, where we define the language, in this case SQLScript. The SQL security, which can be invoker or definer. The values can be invoker or definer, and basically this means which security do I use to execute this procedure. Is it the invokers, the person who's calling this? Is it their authorizations that I use, or is it the definers, the person that created the procedure that I used for authentication or for authorization? The next section here reads SQL data. This means that this procedure is read-only. So if I wanted a read-write procedure where I wanted to do inserts to a table or something like that, all I would need to do is simply omit read SQL data, and it would just have as on this line, and that means that would be a read-write procedure. So this is a read-only procedure, and then anything between the begin and end is your SQLScript code. And in this case, we have two select statements. Very, very simple select statements here. Nothing too complicated to understand. Basically, we're doing a select from the PO headers and joining it with the items tables and producing the number of created purchase orders by the person who created them. Same way with the change, the next select statement here, where we're counting the number of purchase orders that were changed by a particular person. And these are what we refer to as implicit result select statements. So in this case, we're not using any intermediate table variables, and we're not using any output parameters. Okay, so these basically during the call of this procedure, we won't get any results unless we're calling it from a client that can handle the implicit result set. For example, HTTP SQL can do that. So if you're calling this from HTTP SQL and we don't have any output parameters here, we will get the results implicitly. In the next exercise or the next tutorial, we'll show how to use output parameters to get the results. So let's go ahead and save this. And now we're going to do another deploy. So let's go back here to our project and click deploy. And if we did everything right, we should get no errors. That looks good. So let's return to the Database Explorer and open up the container and go to our procedures folder. And let's go ahead and right click on the get PO header data and say generate call statement. And we can go ahead and run this. And you can see that our implicit result set has been passed back to the Database Explorer here. So we see that in result 1 and result 2. And we also have the messages tab here, which shows us the runtime. So let's make sure we pay attention to the runtime here. Again, the idea is that when we add in output parameters and intermediate table variables, that the runtime should be a little bit better, generally speaking. But probably in this particular case, in the trial, and the fact that we're using very, very small data sets, and also the fact that we've had a lot of enhancements into the underlying engines as far as efficiency is concerned, my guess is that the runtimes will be very, very close. Now, if we had millions of rows to be processed here, we might see a significant difference between the runtime of this version of the procedure and the runtime the next time we run it with the output parameters. But just note down the elapsed times here. Okay, so let's go ahead and return to the Business Application Studio. And we're going to further modify this procedure in the next tutorial called Parallel Processing and Parameters. So this is tutorial 2 of the group. And we'll go ahead and edit our procedure. And the first thing it wants us to do is add our output parameters. So let's go ahead and add those here. And again, output parameters are specified here with the out keyword and the name of the output parameter here, in this case, expo create count. And in this case, I'm actually doing a output table and defining it in line with the columns here. This could also be a scalar variable as well, but in this case, it's the table variable. And we want to actually point our select statements to these new output parameters. So the way we do that is we give the name of the table variable, output parameter, and equals, and then the select statement. And same thing with the second one. Okay, this looks good. We can go ahead and say file save and do another deploy. And if we did everything right, we shouldn't get any errors. So let's go ahead and return to the Database Explorer. We'll leave this tab open. We'll try to leave this tab open. There's a little bit of a bug in the Database Explorer where if we change the signature, sometimes it doesn't reflect that here. So if I do a call, if I do a generate call statement here, it may not bring in the new signature. Hopefully we can get around this by doing a refresh here and just refreshing the tree. We'll go to the procedures and right click, whoops. We'll right click and say generate call statement. Okay, good. So if it happens that you do a call, a generate call statement and you don't get your output parameters, then you just click this refresh button here and do it again, and it should work. So go ahead and click run here. And again, we'll get a result 1, result 2, and of course our message is here. Now, so this is interesting. I assume that it would be faster, and it probably is on the second run. So let's go ahead and run it again. And messages. Yeah, so there's always a little bit of overhead on the first run. So just rerun it again and you should get a better result. But you can see here that the run times are very, very similar. Almost negligible, right? But again, the idea of using the output parameters and intermediate table variables is that the engines are then able to parallelize your select statements. And in this case, it is doing that, but we can't see the overall performance boost based on the data set that we're using. Again, if we're using millions of rows, perhaps, maybe if our select statements were a little bit more complex, we will be able to see a difference between the way the first version of the procedure and then this version. So again, just keep this in mind as far as how we're able to use output parameters to trigger that parallelization. But just know that with this very, very small data set and our very simple select statements, that we're not seeing too much of a difference in this case. Okay. Okay, so let's go ahead and return to our tutorial. And the next step is the next tutorial. So intermediate table variables is our next tutorial. And again, we're going to go back and modify our procedure a bit further. And now we're going to get rid of our output parameters. So we'll go ahead and delete those. And we're going to create a new one called EX top 3 employees PO combined count. Okay. That looks fine. And we're going to further modify here. We're going to update the output parameters, and we're going to use what we're going to make them in this case. We're going to make them intermediate table variables, which are implicitly defined. So these aren't defined anywhere above using a declare statement. These are implicitly defined based on the select statement. So basically what we're saying here is allow the system to determine the structure of this intermediate table variable based on the field list of the select statement on the other side of the equation here. So the structure will be create count and created by. And for the PO change count, the structure would be change count and modified by. Okay, so this is implicit declaration. We could use a declare statement and do a explicit declaration, but in this case, we're just using the implicit. Okay, the next section is it wants us to further modify the select statements, add as AID here and as AID here, or sorry, EID. And add another select statement to the end, which is going to basically combine the output of our select statements above and pass that to our output parameter, EX top 3 employees PO combined count. Okay, so here we're doing a select from our employees table and doing a left outer join to our intermediate table variable called PO create count, and a left outer join to our PO, our intermediate table variable PO change count. Okay, so again, using intermediate table variables for our select statements here above, and then doing another select against another database table and integrating the result sets that we already have within our procedure, and then pushing that out to our output parameter. So a combination of intermediate table variables and output parameters. Okay. All right, that looks good. We can go ahead and save and deploy, and hopefully we did everything right. Yes, that looks good. Let's go back to our database explorer, and once again, let's do a refresh just so that we don't run into that problem. And we'll do another generate call statement, and this time our output parameter is a little bit different, and we'll go ahead and run this. And this is our output, right? So let's go ahead and look at our messages. And again, first time running it, it's got a little bit of overhead. Let's go ahead and run it again. In messages, let's run it again. Okay, so it's a little bit slower because we've added some more logic here, but again, still very, very close to the runtimes we were seeing before. Again, the idea here is to demonstrate the fact that using output parameters and intermediate table variables, generally speaking, produces better results than not, because of the way we are able to parallelize the select statements within our procedure. So that wraps up this SAP Tech Bytes video on SQLScript in HANA Cloud. Again, this is the first video of what will be a series of SAP Tech Byte videos covering all of the SQLScript on SAP HANA Cloud tutorials. Make sure to join us next time when we'll cover the 2 tutorials around scalar user-defined functions and table user-defined functions. See you next time.